Welcome to the pre-calculus lesson on angles and sectors. First, we're going to talk about angles a little bit. One revolution around a circle, that would be equivalent to 360 degrees. So one revolution is 360 degrees. This is the notation side here. 1 degree is equal to 60 minutes. Okay, so we're going to talk about a different way of labeling these angles. Sometimes I think of it as a clock. Okay, 1 degree being like an hour 60 minutes. 1 minute has 60 seconds. Okay, so it's just a different way of talking. I could say, why don't we meet up after school after 1.5 hours? Or I could say 1 hour, 30 minutes. So minutes are part of the degrees and seconds are part of the minutes. Okay, so this stands for degree. 1 degree equals 60 minutes. One little apostrophe like that means minutes. And 1 minute has 60 seconds. This is seconds right here. And seconds are like the quotation marks. So what if we have 1 degree? How many seconds would that be equivalent to? 60 times 60, 3,600, if you go directly from degrees to seconds. Okay, DMS, you're going to see that a lot on the paper and stuff. DMS stands for degrees, minutes, and seconds. So if it ever says put it into DMS form, that's what that means. Instead of decimals, they want degrees, minutes, seconds. Okay, we are going to convert these from degrees, minutes, seconds into decimal form. So once again, instead of saying, let's meet up after 1 hour and 30 minutes, you would just say 1.5 hours. So it's the same amount of time. In fact, when I'm doing this problem, I know that this is going to be 81 point something degrees. An 81 degree angle with some minutes and seconds is still going to be an 81 degree angle. Okay, and I'm going to show you how to do all this just on your calculator. So go ahead and get those calculators out. Okay, the first thing we do is type 81, and you have to find your angles command. The angles command, where should I put this way up here, is second angle, and the first one is the degree bubble, so 81 degrees. Now we're going to type 30 minutes, so type 30, get back into your angles command, and option number 2 is minutes. And this is where it gets a little tricky. 12 seconds. If you go back into the angles, there are no seconds. And if you try doing minutes, it just won't work. Okay, so that's not the right place. We have to find the place where we could put a quotations mark. Okay, and it's somewhere on your calculator. In fact, it's way down here above the plus sign. So we need to hit alpha plus. There's the seconds. And all you do is you simply hit enter. And so this angle is 81 point, I'm going to round to 2 places, 50 degrees. Well, that makes sense. 81 degrees, 30 minutes, that's like half, so 81.50. All right, let's try it again. Let's try 50 degrees, 20 minutes, and 21 seconds. And that comes out to be approximately, I know it's going to be 50 point what? Let's round to 2 places. 4 degrees. Okay. Now let's take an angle that's in decimal form, and we're going to convert it to DMS, degrees, minutes, second form. Okay. So what we're going to do is we're going to start off by typing. Let's clear that out. 45.53. And I'm going to convert that to DMS form. So we're going to go back into our angles command, and there it is, option number 4. Change it to degrees, minutes, seconds for me. 45 degrees, we've got 31 minutes and 48 seconds. So a 45 point something degree angle should still be a 45 degree angle. All right, please try the next one. Okay, and we have 21 degrees, 15 minutes, And this is saying 21.6 seconds. And that's kind of weird. We don't usually put a decimal in there because they don't want decimal form. So I'm going to round that to 21 degrees, 15 minutes, and 22 seconds. Okay? We don't want any decimals in DMS form. Let's just put a little note here. To convert degrees into decimals and from decimals to DMS, these commands are located in your angles command, your angles button, which is above the apps. Okay, so just remember where you found those. All right, that makes that real easy. What else are we going to do today? Let's talk about arc length and sector. Okay, so if you don't have an entire circle, but just a piece of it, a little pie, one slice of pizza, there's a couple things we can do here. Okay, the first thing is arc length. Arc length is always represented by letter S because it's curvy. So how much of the circle is this much? Notice I didn't go around the circle, I just went this much of the circle. So how much is that? Well, it's a certain fraction of the circumference. Is that half of the circumference? Is it 1/4? Maybe if that angle was 90. So what you're going to do is you're going to say, what is that angle? And you have to know the radius, of course. So you say, how many degrees out of all the degrees? How many degrees are in a circle? 360. So I have theta degrees out of 360. That's a fraction of the circumference. Of means times, and that would be 2 pi r. So this is a great formula if you have degrees. What if they give you radians? Okay, well, we'll do the same thing. We'll take the angle out of the whole thing. How many radians in a complete circle? 2 pi radians. And I'll multiply that by 2 pi r. That is an excellent formula because you understand how it's made. It's a fraction of the whole. There is a cleaned up version of this. If you cancel out the 2 pi's, all you get is theta times r. That is the angle in radians. And what I usually remember is radians times radius. Okay. Otherwise, just knowing how they're formed is actually really good. Okay, let's talk about the area now. The area. How much area is in this little slice of pizza? It's going to be done the same way, same process. This is not the entire circle. It's not half the area. It may not even be a quarter of the area, but it's certainly a fraction. It's theta degrees out of 360. It's a fraction of the area. How do you do area of a circle? Pi r squared. And then same thing for radians, except it would be the angle out of 2 pi radians times pi r squared. That's a great formula right there. If you'd like to see the cleaned up version and cancel a pi and a pi, then what you get is 1/2 theta r squared. But you certainly don't have to remember or memorize these made-up formulas here that were simplified. You could just know how to make the equation. Okay, we are going to find the length of an arc of a circle. The radius is 2, subtended by a central angle. All right, that's really weird, but subtended means formed by or cut off, and then formed by. So let's go ahead and draw a cute little picture of what this is going to look like for you. There's a circle right here, and the radius is 2, and the arc that's subtended or cut off by this angle is this much arc. I'll call that S. And the angle right there is 0.25 radians. So we're going to find the length, the arc length. So we've got our angle out of 2 pi, 0.25 out of 2 pi, times 2 pi r, which is 2. We could have used this formula here even, radians times radius, because both of those 2 pi's just cancel out. And so what is 1/4 of 2? Well, it's just simply 1/2. And I don't see any units, so I'm just going to say 1/2 units. If the problem said feet or meters, then I'd say that this was 0.5 meters or 0.5 feet. Okay, find the area of a sector. Okay, so now we've got a circle with radius 2 feet. Radius is 2 feet. The angle is 30 degrees. 2 feet. And we have to find the area. So that's all this space right here. State your answer as an exact answer. That means the full and complete answer. The full and complete answer, nothing chopped off. And as one rounded to 2 decimal places. Okay, the area of a sector. Area equals. This is a fraction. How much? It's 30 degrees out of the full 360. It's a fraction of the entire area. Area of a circle is pi r squared. Okay, so we can cancel 0, 0. We can cancel 3 and 36 to make a 12, but there's a 4. So the exact answer is pi over 3. And then the rounded answer, if we type that into our calculator, and we do pi divided by 3, that is approximately 1.05, and the units here are feet squared. Exact and rounded. That's how I'm going to say all the answers. Okay. This is a very famous problem because this physicist here, he developed a Foucault pendulum. Okay, and with the Earth's rotating, there's some swinging going on, and this is how he demonstrated it. He took a really, really large, heavy brass ball, and he put it on a 55-foot cable, a 5-story cable. This thing's huge, hanging in the air, and it's way down here. 55-foot cable, and it swings. Oh, this is a terrible picture. 2 degrees is way tighter. It's just going back, but I had to make it a little larger here to fit my numbers. Okay, 2 degrees. How far does it travel? Well, if this pendulum got out of control, that would just be on a circle. It would be on a circle, so that would be an arc. So this looks like a fancy arc length problem. How do you do arc length? The angle is 2 degrees out of how many? How many degrees in a circle? 360. And this is circumference. So that would be 2 pi r. Okay, so what we're going to do is say the exact answer here, equals the exact answer. So I'm going to type 2 divided by 360, and then I'm going to multiply that by 2 and by 55. And what I'm going to do is math fraction, number 1, math fraction that up. I typed everything except for the pi. So the answer is 11 pi over 18 feet. That's the exact answer. And then if you want to make an approximated answer, you have to multiply that by pi, get a lot of decimals, and it's about 1.92 feet. There's the exact, and then there's the approximated answer. So this pendulum only swings back and forth 2 feet. But it's just swinging back and forth because the Earth's turning, so that is quite remarkable. Okay. We got a couple more fancy problems here. Just fancy ways of saying do some arc length or area of a sector. We have 2 boats leaving the port at the same time. Okay, so let's just draw a little navigation. And remember how I said boats work with navigation? They don't care about the x-axis. They care about due north. Okay, one boat leaves at a 30-degree bearing. A 30-degree bearing, starting at due north, puts this boat about right here. Okay, so I'm going to say that this is boat number 1. Oh, that's a cute picture. This is 30 degrees. All right, now where's boat number 2? Boat number 2 is at a 50-degree bearing. Okay, starting at due north, but this one's going to swing a little bit farther. It's going to swing 50 degrees, and this is boat number 2. Okay, he swung 50 degrees. How far apart are the boats? Okay, now this question is a little more abstract. These boats are on the Earth. And you guys know about this Earth thing? It is round. Yeah, believe it or not, the Earth is round. So when you're calculating distance between boats, it's on the curvy Earth. So this is a very, very fancy way of saying find an arc length. Find an arc length. Okay, I know how to do that. Arc length is angle out of 360. Okay, what's the angle that this arc is using? Is the angle here for this arc 30 or 50? What do you mean it's neither? The angle between the two rays forming that arc, between here and here. Oh, 30 and 50. It's the difference between them. This angle is 20 degrees. Okay, I'm going to write this a little weird over here for future reference and stuff. This is 50 degrees minus 30 degrees. And you're right, it's just 20. Okay, so we've got angle out of 360 times 2 pi r. Oh, wait, I need the radius of the Earth. The radius of the Earth. Oh, no. Oh, 42 miles from the port. I'm sorry, 42 miles. There we go. 2 pi 42. Okay, so let's go ahead and type that in and see if we can get the exact answer. So 20 out of 360 times 2 times 42. I'm typing everything except for the pi, and then I'll fraction it up. So the answer is 14 pi over 3 miles. Or, if you'd like an approximate answer, go ahead and multiply that by pi. And it makes 14.66 miles. Okay, there's the two different versions. Exact answers are perfect. They're not chopped, but sometimes it makes more sense for people to hear a decimal. They get a better idea of how far it is. Okay, last problem. We've got Glasgow, Montana, due north of Albuquerque, New Mexico. So once again, let's draw an Earth. Let's draw an Earth. And we've got one city here on the Earth, and it's due north of another city. Okay, so this is Glasgow, and this one is Albuquerque. Okay, Glasgow is located at 48 degrees 9 minutes north latitude. Albuquerque is 35 degrees 5 minutes north latitude. Okay, and we have to find the distance between them. Okay, so once again, we've got a distance here on this curvy Earth. So this is going to be arc length. Arc length. So how do you find an arc length? We need to know this angle. The difference between these two. Let's put the big one first. 48 degrees 9 minutes. And I have to subtract 35 degrees 5 minutes. That angle out of 360. And this is circumference, which is 2 pi. And this is the one here that needs the radius of the Earth. The radius of the Earth is 3960. 3960. Okay, let's try doing this one. 48, let's use parentheses here. 48 degrees 9 minutes. I'm going to subtract 35 degrees 5 minutes. Okay. And we're going to subtract those two, divide by 360, and then we're going to times by 2 times 3960. Does this answer fraction up? Oh, that is really large. This does not make sense to a lot of people. Hey, how far do you live from school? Well, this is ridiculous. But this is the exact answer. And I think one that would make more sense to a lot of people is if we told them the one with the pi. Well, the two towns are 903 miles, 0.10. That makes a lot more sense. So with this kind of problem, I think I'd put this one on the answer line. 903.10. Okay, have a great night.